Je cherchais quelque chose pour noter.
Merci. Ah.
So etwas durch die Treppe auf.
Ja, ich finde, ein bisschen
Probably because we put that song on it. But that song we can always interview because we see him every day in the office. So.
Okay. Not bad, huh? This is our electronic record. And you see on the map there are some white areas where it's possible to overtake, and these orange areas are areas where it's not recommended to overtake.
And what do you mean precisely by overtaking?
If you would like to overtake a car.
Yeah.
Yeah?
By crossing,
By-
yeah. Okay.
By overtaking.
Yeah.
Yeah?
Okay.
Or passing. So, huh?
Passing.
Yeah. And you see, now is the area coming where it's possible to overtake.
Okay.
And this is this area here. Yeah?
So always on straight lanes, basically.
There is, we are on,
Or a curve that's not too hard.
on the country road. Huh?
Yeah.
Yeah. And this is also the velocity which is allowed here. And if you are faster than 70, then it changed to red.
Okay.
Yeah? Yeah? And now you can see this is white. And now, if you would like to overtake, you have the possibility to overtake. Yeah?
And
But you have to look for the oncoming traffic. Yeah?
Yeah.
It's clear.
And does it sign that as well, or only the overtake possibility?
Because we from BMW saying you have to have the fun of driving, and you are responsible for your driving behavior. Yeah?
Okay.
We are not using any other sensors. Yeah? Now you see, there's no possibility to overtake. Yeah? And this is what I'm seeing on the head-up. Yeah? Now this electronic horizon is looking in front of you, about 2 kilometers. Then he's showing me this wide area. And this is dynamic, because if I'm driving slowly, then my overtake distance is short. If I'm driving fast, my overtaking distance is longer. And this dynamic is shown by this bar.
Okay. So, I understand. So this is especially interesting in France at the Mediterranean parts.
The mountains,
mountains, the Alps.
And now, if I would like to overtake, I'm gaining time. Because now I know I would like to overtake, and then I can say, okay, I'm overtake, Now here's the curves, not anywhere allowed, and we are reaching this area, and there's a crossing. Let's say we are not, or the driver is not recommended to overtake because here's a crossing, it's dangerous, and also if we are reaching this town area, we define this as a small town, and then this bar indicating, okay, now we are reaching a different area.
Okay.
Maybe a city or a motorway, because the functions only works only on country roads. And now this is changed to a city.
Okay. Okay. And this is the map is shown by a GPS system, or is it by GPS system?
Ja, nu passeert er een auto voor. Ja.
Okay. And you could explain to me in the mirror. You can see me in the mirror.
Okay. So. Now I'm presenting a dynamic path prediction, and what we have done is that we are combining the maps and the driving dynamics of the car. And in general, you see on the map the static data of the geometry of the map, and then we are putting over this map, or we matching the driving dynamics of the car during your driving with the map.
And is it restricted to speed limits, or?
It is restricted to the normal legal speed limits. And if we present this to the driver, on one hand on the navigation display and also on the head-up display. And if it is orange, and you can see it's not recommended to overtake. And if there's a white bar coming, and then the driver can see on the head-up display or on the map, there is a possibility to overtake, but he has to look whether there's oncoming traffic or not. He's responsible when he is driving.
So it's very important to make sure that even though you visually look for no danger, basically, it's only an indication.
Yes.
And how about
is the information for the driver?
Okay. And how about the white blocks, and how because they vary a little bit? How this is possible?
Yes, this depends on the driving dynamics when you are overtake, and because when you are driving slower, then your overtake distance is shorter. If you are driving faster, then your overtake distance is longer. And this is matched with the map. That's what you're seeing on the bar, because this wide area is dynamic on the head-up display and on the navigation screen.
And is it only specially designed for the BMW series, or could it go with any possible car? Basically?
Normally it could go to any possible car. And now when you are reaching the city or the small towns, this also includes that we are not driving too fast in cities. Then we are not recommended to overtake. Or if you're coming crossings like here, if you're seeing a crossing, then it's also not recommended to overtake, because these are dangerous situations. And this is also then shown on the CID and on the head-up display, that if you are reaching this area, then the bar is shrinking and is changing to a city sign. And also the velocity is changing to 50.
And this is based on what kind of system then?
This is based on the BMW navigation system.
Okay.
And on the driving dynamics of the car. Because every car has different driving dynamics.
So it's adapted to the engine as well?
Yes, also adapted to the engine. Because this car is faster to overtake, and another car needs 530. But you see, we have only 70s allowed here. We are trying 50. And if you're now faster, then it's changing to red. See? Speed sign is then changing to red if you're too fast. Yeah?
But basically it's a GPS system.
Yes, yes. Because this is a normal navigation system for BMW, and this works with GPS.
Ja, die inhaalman heeft nog eens geoefend.
Dat gaan we toch niet.
Now change to red. Yeah?
Ja, dat heb ik ook.
And then, because sometimes you always forget how fast, or which velocity is allowed to drive. And then you say, okay, we put it on the screen. Yeah?
What's your opinion of the driver could get distracted?
Ja.
Okay. What are the benefits of the technology used in maps and ADAS?
Oh, you are more safer on the road. You can drive more safer because you are using the maps and the driving dynamics of the car, and then you know where you are. You have an electronic horizon, and this is more safer to drive, and you can drive relaxed then.
Okay. And what do you think is its innovation? What makes it unique compared to other technologies today?
Oh, this is the first time where we have matched the map data with the driving dynamics from the car. This is the innovation, because this was never done before.
And what do you think its implementation prospects are? When do you think we'll be able to walk into a BMW dealership and see it on the car that we're picking out?
Well, I mean, I told you a lot, but I will not tell everything. But I think as soon as possible we will have it on the car.
Okay. And what aspect of the project has impressed you the most? What are you most excited about now that you're finishing up with the work?
Oh, but working together with people from PReVENT and also develop new systems. This is the main point.
Okay, thank you very much.
Okay.
I hope they weren't too difficult.
Take him. Yeah, you can say his name.
It's Jan Loewnau from the Maps and ADAS project.
Introduction then, and we always have it in up front.
Yes,
We
that's a good
can
idea. Okay, can you tell us your name and the project that you represent?
So my name is Gerhard Noecker, and I present the project WILLWARN, which is standing for Wireless Local Danger Warning.
Okay, could you tell us a little bit about the benefits of the technology used in WILLWARN?
Yeah, we found out in simulator studies that if drivers, if they are informed earlier on hazards, they can react earlier and traffic becomes much safer. And so we have built up this communication-based system where all the cars here in our demonstration are communicating with each other, and they tell the others what they know about hazards on this test track and later on ordinary road.
Okay. And what is the main innovation in WILLWARN? What makes it unique to some of the other technologies today?
So for us it is unique because we have built in this project the whole function. Starting with the in-car detection of the hazards. This means detecting bad weather conditions, low friction, obstacles on the road and so on. And we have a warning management in the cars, so all the cars take the knowledge on the hazards with them and distribute it to each car they are meeting. So we have not this information hopping in a queue where we need a 100% equipment rate. Even at lower equipment rate, vehicle can talk to each other and inform others on hazards. And no of these warnings will get lost. We will keep them in the cars for some time, and we will store them and forward them to the other vehicle.
And what do you think its implementation prospects are? When do you think we'll be able to actually see this technology in the cars?
So it takes a little bit time because we need frequency allocation for Europe. We apply for the 5.9 gigahertz spectrum, but we are confident that we will have this in 2010 or perhaps a little bit later, and then it requires some more large-scale field operational tests, and so I think at 10, 15 latest we could come to the market.
Okay. And what aspect of WILLWARN has impressed you the most? What are you most excited to see come out of all of this?
Most impressive is that cars of different car manufacturers are talking together. So this means it is not a company system, but it is a European system for all car manufacturers, and this allows us to have a bigger benefit for all car drivers.
Great, thank you very much.
Ze is ook nog tegen de wind in langs daar. Totdat ze komen. Hè. Even checken of er niks is.
Kijk, ik kan eens al wat spullen opzij leggen. Dan moet het wel niet nat worden.
Wacht hè. weer niet aan de parade. Maar dan hebben we gewoon een reisje. Nog een jeepkist. We zijn er nog.
10 minuten. Dat is een toffe deze.
Zo, dan gaat het juist weer. Ja, oké.
Oké, dat is nog interessant. Zet je weer in binnen. Oké, die andere pakken zijn daar.
Nou is er nog een.
Een truc.
10 van boven erop hangen.
Hi, will you take images now, or
Yeah,
of all the cars, or?
yeah. Just because I took. beter.
Dat was het. Alhoewel, nodig aan dat was er niet staan.
Zakenmensen zien ze graag. Dit is een stel. Een Italiaan. Hello. Dat is. Dat is fantastisch.
So, okay, well, we are more or less set on the position of the different cars, but what we see right now is that there is a lot of space there to our friends that don't have any cars, and basically what we should try to do is to fill in the holes. I think the order of the cars is right.
That means that then when this kind of wraps up at whatever that you guys are,
training, you can, after this one, you can focus still on doing all the demos.
Yeah, because that was a big and if we get that done, then we can say that we have.
Ik vrees dat er niet veel meer volgend jaar.
If there is any problem, please raise your hand right now. There is no problem, so then we just head back to our demonstration area and then we start again until 6 o'clock. Wait 2 seconds, Jan Loewnau are responsible for... Yes, there is one very major thing that
Leuk. Ja. Het zal een goede tele pakken. Dat is het belangrijkste, dat we die hier, dat is geen schoon beeld.
Okay, next suspense cars. Mercedes car. Okay, the in-safe car.
De eerste. Ja, sorry jongens.
Ja, kom dan. Dat is het voorlopig.
Ja?
Ja. Bus achter. Dat is waar. Een shuttle af.
Een shuttle. Heb je geen dikke portefeuille?
Ja, nog niet.
Heb je geen dikke portefeuille?
Wat?
Een dikke portefeuille? Wacht. Oh, ik heb mijne al.
Je hebt je eigen. Ja, dat is een mij. Wat heb je staan?
Nou, juist uit beeld, dus dat maakt niet uit. Is er nog iets?
Normaal gezien komen er nog 2 af. Maar
Oké.
ik zie nog niet direct afkomen. Die zijn wel precies wel lang.
Ah, ja.
Kan ik zo uitnemen, eller?
Sterk. Super daarachter. Speed komt er nog eens wel.
Na die shuttle of?
Dat is een shuttle.
En dan die zwarte direct erna?
Nee, niet direct.
Ah. Ja, ik heb hem. Shit. Ja. Pak die kant van mij.
Is daar. Okay, so this is a driver warning system which was developed within the sub-project Maps and ADAS. So the main goal of Maps and ADAS is to focus on safety data which could be put into
Start driving so it looks more dynamic, and then the moment he starts driving, you just start your.
Okay.
Okay, so you can start.
And maybe it's best to talk to her
So-
and not directly into the camera.
Okay, I just put the...
Yeah.
Okay, so this is a driver warning system which was developed within the Maps and ADAS sub-project of PReVENT. The goal of Maps and ADAS is to focus on safety data which could be added into the current digitized map to improve the security. And during this sub-project, the whole data change has been considered from the data sourcing to the navigation system, and we also experiment and develop standardized interface to provide information and map information from the navigation system to the application. So different map navigation system provider developed this ADAS interface, and some interoperability tests were done successfully, and we use this interface here for this application. So the driver warning system here is just a system composed of two applications: a speed limit warning system, which informs the driver about the current speed limit and warn the driver in case he's speeding. And the second application is a hotspot warning system. So an hotspot is a dangerous area which is defined based on statistic accident data, and we use this data to define the area where there is a potential risk for the driver. So we try to warn the driver a little bit in advance. There are some parameters we can adjust, for instance the preview time or the preview distance when come the warning. And for the hotspot data, for instance, there are several warning speed. So
What does
this
that
is
mean with
this is an hotspot, so we use a special traffic sign in order to not confuse the driver with real traffic sign, because hotspots doesn't correspond to real traffic sign. And yes, for each hotspot we have a warning speed, and when the vehicle is exceeding this speed, an hotspot is providing. And we consider different type of situation in order to not overload the driver. And this warning speed varies according to environmental condition. This means when it's raining, the warning speed is lower. When it is night, the warning speed is also lower, and we also consider freezing temperature, for instance. That's for the hotspot. Just have to check that some problem with the positioning. Just have to reset the vehicle. It's okay. And so the goal of all this warning is really to measure the impact of safety data on the driver behavior. Some tests were realized by the University of Hanover. We have a test track around Hildesheim, which is a place in Germany, and about 60 drivers did some tests and then the results and the record were analyzed, and each driver did the test track twice. The first one without the system, and the second one, the half part of the driver did with the system and the second part without, in order to have one control group and one experimental group. And the results show that with this system, a reduction of the average speed has been observed of about 3 km/h, and the duration of the speed limit exceeding has also been observed. So, during this second lap, we drive faster, so that is the reason why there is some more hotspots, because we are driving over the warning speed more often than during the first laps. So, and when it's blinking, this means we are speeding, and the sun comes when we are really speeding. And we can adjust the threshold value about the speed limit to set up the blinking or to set up the acoustical warning. So that's it. I don't know if you have some questions.
I think it's covered.
snel. Die baas zit in de andere.
Nee, de baas zit in deze. Ja, die is verplaatst.
Ah, die is verplaatst?
Ja, hier, voilà, nu komt hij eruit.
Ja. Langs achter?
Ja, nee, hier, voilà, eerst rechts zo.
Ah ja. Dikke extender nog op.
We gaan nu erachter mee.
Ja.
Voilà. Als we daar een glimps van hebben.
I think I will start. Perhaps you can also.
So I might tell you when
We're at the point.
when it's supposed to come about. So there will be something moving on. So. Mach keine hartes Bremsen.
Ja, ich mache
So normally we do a hard braking maneuver in front of the so that's not that nice. So. I didn't know that it's coming so soon. Fahr mal langsam. The last one I really know that it's coming right now is a pedestrian should be somebody.
noch eine Runde.
Should we take one more round or is
Yep.
that okay for you?
For me, I saw the screens actually.
So it's okay?
Yeah.
Okay then.
You only have. Oh, 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 oh. Damn. Just push the button. Yeah. You can come around to the first stop step. Now we're heading towards the roadworks. Yeah. Am I too fast? Yep. It's okay. want to do another turn? No, it's okay.
I explained something about it?
No, because we have the explanation of the project leader.
Okay. Then we drive about 1 kilometer to this slippery surface.
Yeah.
I will drive on the surface to make an ESP intervention. I will steer and the car goes into understeer.
Ah, okay.
And the ESP will regulate the rear axle.
Ah, okay, yeah.
Maybe I switch off this one. It's better. Yeah. Now we are too slowly.
Ah, okay.
Nothing happens. May I drive
Yeah,
back?
you. Yeah.
Okay.
Yep. Okay, I'm going to get close. Very good.
One more time?
One more time, yeah. Yeah, here we go. Okay, very good. We can go back to
Maybe
Kommissarin wieder, und dann geht's aber raus. Alles assimiltiert. Ja, dann gehen wir rüber und dann ist die Öffnungssession und dann danach ist dann die Mikrofon gemeinsam mit Dreisatz und dann Nachmittag kommen wir noch bis abends.
Ok, bonjour tout le monde. Bonjour. Bonjour.
À la table, là-bas, s'il vous plaît.
Peut-être vous serez pas. Moi j'ai
Monsieur Balas Ramanian de Jan Loewnau. Stehen Sie allein?
I start.
Yeah.
Okay.
Ladies and gentlemen, can I have your attention for Commissioner Viviane Reding, EU Commissioner for Information Society and Media.
Well, ladies and gentlemen, you might ask yourself why the European flag is flying on this event. For a very simple reason. Because this is a European event with not only the political drive of Europe, but also the financial and the legal drive of Europe. Now, Europe has set the target, and the target is fatal road accidents should go down by 50% up to 2010, and 2010, that's pretty soon. Now, what is the concrete steps we have decided in order to reach these targets? One of the concrete steps is to utilize ICT, information and communication technologies, in order to achieve the targets. And of course, this has to be done first through research. Research is the basis, and we have invested only this year